Okay, today is our review for the big test. And the test is tomorrow, and it's on identities, and it's never a fun test. Uh, Yesterday, I hope you were really paying attention well yesterday. If you missed yesterday for some reason, you need to go back and watch the videos for that. I'm going to, in an unusual case like this, I'm going to post them on Schoology so you can know what yesterday's video was. So if you weren't really paying attention well, you can go back and watch it again. Because yesterday's, I warned you ahead of time, would have two of the questions are from yesterday's material. Okay, so you really needed to pay attention there. And I am going to be reviewing, of course, today. But yesterday's video, kind of a big deal. All right, sine of 2x. Find it on your sheet and circle it. Can you guys stop talking right now? Thank you. Find sine of 2x on your sheet and circle it. I don't see circling happening. Find it on your sheet and circle it. You will need a pencil or a pen, I know. The reason I'm having you circle it is this one is one of the most important ones. It comes up on like trig tests in calculus. They expect you to know this one, memorized, not on a sheet. So might as well get it used to it right now, kind of learn it. It's really pretty easy. It's got a 2 in front of it. And there's a 2 in it in a weird place, right? So obviously that 2 is going to draw your attention. Sine of 2x. And see if I can find the dice. There they are. Dice of destiny. You're going to read me what it says on the sheet about sine of 2x. And the first die is out. The second one is trapped in some weird pocket within a pocket. All right, there we go. Row 6, second person, that's you. What'd you find? 2 sine x cosine x. Well, that's pretty handy because you all know how to find sine and you all know how to find cosine. All right, so I'd like you to find if x was 30, find sine of 2x. Well, you might be like, isn't that the same as sine of 60? Well, it's actually 2 sine cosine. Here's your triangle to remember what sine and cosine are. And if you haven't memorized sine of 30 by now, this is the 37th time it's come up. What is sine of 30? You didn't know? Boo. Sine of 30? 1/2. All right, good. So I'm going to go 2 times, what is sine of 30 again? It's 1/2. And then what is cosine of 30? Well, look it up. Look on the little triangle. That's why I have the triangle there. This triangle right here. So cosine of 30 is √3 over 2. Awesome. Now multiply that all out. Well, 2 times the 1/2 just kind of disappears, doesn't it? So it's just √3 over 2. All right. And couldn't you have just looked up 2 times 30 is 60 and said sine of 60? Yeah, because the sine of 60 is √3 over 2. Okay, so moral of the story is that you need to memorize this. Well, not really, because I'm giving you a sheet, but I'm telling you that that's one of the ones that's on the AP test. It's called a double angle. Sine of 2 theta is 2 sine theta cosine theta. All right, now let's see if you actually learned something there. This is a proof. On your own, you should now know pretty thoroughly what sine of 2 theta is. Prove that sine theta over sine of 2 theta is equal to 1/2 secant theta. You need to show me every step. I know this is true. You can't just say that, 1/2 secant theta is 1/2 secant theta. The point is you got to get from here to here and show me the steps. I know this is how it ends. It's true. That's how it ends. But you need to show me all the steps in between. All right, this is the other one I want you to do by yourself. Now, your homework for tonight, and I'll try to remember to reiterate this later, but your homework for tonight is to do 4 practice problems. 4 practice problems. You may even repeat one of the practice problems I'm doing with you right now in class. You just have to do it over from scratch. You can't just take a screenshot of your work. Okay? And that's one of the 4 things you're going to do practice tonight. So what are the other 3? You go back and find 3 other problems that you think would be good to do. There has been a ton of things assigned where you have the answer keys for them. Go back and find old homework assignments. Find 4 problems you think would be good. One of which can be this. You could even do this problem over again if you want to. I wouldn't. It's a pretty easy one. But that's your homework, and be prepared to drop that at a Dropbox tomorrow. And I guarantee you there's going to be some kids that are like, what, there's homework? Yes, I just assigned you homework. And I just told you you're going to have to Dropbox it. What was it? 4 problems of your choice that you're going to do and put into one Notability doc so you can drop that one document in the Dropbox tomorrow. Because that's what you're supposed to do for reviewing. It's find old homework problems, try them out. You can even make up the problems yourself if you want to. I think it's actually a lot harder. I think I'd just go find old ones. And then the last thought is, would you want to partner with somebody who didn't do any homework last night? Wouldn't you rather partner with somebody who actually studied last night? You know what I mean? So don't be the weak link. Don't be the kid nobody wants to have as their partner because, like, yeah, I was too busy. Sorry. Well, great. You're going to be a great partner then. All right. So first up, you should have, can you replace sign with something? Yeah, but that's probably not the best way to go. Take the complicated part, which is right here, and already, hopefully, you've got it memorized. 2 sine cosine. So now, I'm going to rewrite this the way I would want to see it on the test. I would have the kid put the top part as sine theta. There's no change there. So, and I direct the teacher's attention to, look, I changed 2 sine theta into that. Next, I'd have the kid put a parenthesis around those to kind of call that out and go, look, I see a sign on the top and a sign on the bottom. And then can you do basic math? Yes. So only one thing, though. I did that one thing. Now I got to stop and rewrite it. Hopefully you know there's a 1 on top, 2 cosine theta. And if you left this, that is not on the sheet. There's nowhere on the sheet where it says 1 over 2 cosine theta is 1/2 secant. There's no such thing. So you can't just make that leap. That happens all the time where kids are like, well, I know it must come out to this. I know it has to be 1/2 secant theta, so I'll just say it does. No, you have to show me how it does. So how could you show me that that is going to become 1/2 secant theta? I would recommend, since you know it's supposed to be a 1/2, right? Maybe break the 1/2 part off in the front. And then what do you have after you put the 1/2 in front? 1 over cosine, yes. And then you can take the last step, which is 1/2, and everybody can see that on the sheet. 1 over cosine is on the sheet, and that's secant. That's how you'd show that final couple steps. Okay. There. Now this is equal to that, and I have got a proof done. All right, this is the part where you practice having a partner for the test. It is not going to be the person sitting right next to you. I guess it's possible. There could be a few cases where they have the same grade, but I'm going to assign the partners. You're not going to be able to say, can we work together? I'm going to assign them. These 2 rows slide next to each other. These 2 rows slide next to each other. These 2 rows slide next to each other. People that don't have partners, you can figure out how that works. Try to find somebody you want to work with that doesn't have a partner. And pausing for a second while we get partner groups. Okay, let's see how I did. You should have said that it was in quadrant 2, which is like this. You should have said sine is opposite over hypotenuse, 1, 5. You should have said this was the square root of, and you got 25 and a 1, so therefore it's 25 minus 1 is 24. And you hopefully, After my coaching, remembered it was negative. Somebody probably still forgot, but anyway. Then sine of 2 theta. I can't do that directly. That's why we need that thing. We need that identity. So CA in the back, what is sine of 2 theta? What? Not the final answer. What did you find on the sheet for sine of 2 theta? I'm going to replace this with what? Maybe you didn't do that, in which case, okay, then what is it? Wait a minute. First tell me what it is. What's on the sheet? The sheet says what? 2 sine x. There you go. Good. That's what's on the sheet. Now we have to do what that is. 2 times what is sine x? That I can look over here for, or even up here. It's 1/5. And then cosine x. That's adjacent over hypotenuse, which is negative root 24 over 5. And I know some people would have just left it this way. You definitely lose points. Some people who put it together thought they were doing a pretty good job, still lost points. Why? It's not simplified all the way. What's the square root of 24 break into? Root 6, root 4, which is really 2. 2 root 6, negative 2. Put the 2 and the negative 2 makes negative 4 root 6 all over 25. Yeah, it is easy to forget that simplifying. Okay. Here's one, and this time you got to remember, it's like last time, except it's got 2 parts. So this part, I'll draw blue from the blue one, and it needs a triangle drawn in a certain place, and all of its sides and angles, and that's angle alpha. Then this red one needs a separate thing drawn, and it's going to be a triangle with the angle beta in it. Then you got to look up this on the sheet and figure out what it is so that you can get the final answer, which again will look like last time, something like, 5 root 3 over 2 or whatever. Okay? So draw your separate triangles, label all the sides. It's all about drawing triangles. You can't do this with the unit circle. It's where its limitations lie. All right, I'm going to pause while you give this one a try. Okay, on this one, cosine is negative. That tells me right away that it can't be here and it can't be here. That's how you should think that through. And then if tangent's negative also, then you should be able to say it can't be here, and therefore it must be here. Now, within that, I have cosine is adjacent, negative 4, hypotenuse 5, and I recognize the 3, 4, 5. Awesome. Okay. Then I'm going to think, what angle is that? That's angle alpha. And it's smart to label it in there, because then later when they're asking, like, what's cosine of alpha or sine of alpha, that's the triangle that gives you alpha. Now I'm going to go and do this one for beta. I'm going to do that over here. And tangent is negative. All students take calc. If tangent's negative, it can't be here and it can't be there. And now I'm left with sine, the S and the C quadrants, second quadrant, fourth quadrant. So beta is in, it says it's in quadrant 2. Well, and I could have just gone right here in the first place. Okay, don't try to put it in the same exact place as this because they're not the same. They have different sides. Tangent, TOA, opposite, adjacent. And did you catch that some people are going to put a negative 1 the 1 because there was a negative up there, but the side that's actually negative is the 4? See what I mean? You got to pay attention to that. All right, then the next step is 1, 4, I don't know, so I go square root of. 4 squared is 16, and 1, do I add them or subtract them? Square root of 17. There, and now I should label that with B for beta. So that's the beta triangle. Now, I need cosine of alpha minus beta. Did you find it on the sheet? Awesome. What did you get for that? Did you find it on the sheet? Excellent. What was it? Sine of? There's alphas and betas. Okay, there you go. cosine alpha sine beta. So sine, sine, cosine, sine, that doesn't seem right. You probably said it. Okay, so at the end it's cosine. All right. Sine, sine, cosine, cosine. Does it really have a plus in the middle? Just make sure. Okay, because everything's got to be right there. This is all going to get fouled up. All right. Now I put in what each thing is. Only one of them was known. I knew cosine of alpha was negative 4/5, like right off the bat. It's right there. But the other three, I have to go look at triangles to find them. Sine of alpha, I go to the alpha triangle. It's right here. Sine is opposite over hypotenuse. It's 3/5. Sine of beta. Beta is down here. Sine is opposite from this angle's perspective. Opposite over hypotenuse. 1 over root 17. And then the last one is cosine, which is adjacent over hypotenuse, is negative 4 over root 17. And that's 3 on the top here. And positive 16 makes 19 over 5 root 17. That's it. It's pretty intense. How many of you actually pulled that one off? Yay. Okay. Then your next one is a proof. So this proof is already like most of the way done. I just kind of want to walk you through it. So I've got 1 minus cosine theta on the top, and I'm replacing it with sine theta. Do you get that? Do you know that that's the same as that? If you don't know that, you got to learn to find those on the sheet. Those are a big deal. It's the top left corner of the sheet, except it's been rearranged. All right. Next, you'd have to find sine of negative x. Do you see sine of negative x on the sheet? All right. So now I want you to prove that this 1 minus cosine squared over 2 sine of negative theta is equal to sine theta over negative 2. I could have said negative 1/2 sine theta, but I think this will be a little easier to prove. So I'm giving you a fairly easy one here, and then we'll ramp it up on the proofs. Okay, this was an easy one. That one's sine squared over 2, and I'm going to break one of my own rules here just in the interest of time. This right here can be replaced with negative sine of theta. Okay, you can't just overlook and say, oh, there's a negative here. Let's bring it to the outside. That's not a thing. But if you look on the sheet, that is the same as that. And that's a substitution you can do. Now, don't try to do 2 at once like that. I would not let you do that. But I'm trying to get through one more problem in class here. Then I'm going to have, let's see, sine theta times sine theta over 2. And I'm going to throw the negative on the outside because that's only one extra step, multiplying by the negative 1 in front, right? Negative 2 sine theta. Then I'm going to call these out. I am okay with this, just like putting parentheses around those and go, see, there's one on top and one on the bottom. And that leaves us with sine theta over negative 2, just what we wanted to prove. So I'm going to finish it because you do have to have exactly the same on both sides. But don't try to skip any steps. All right, next thing. Wait a second. I need to show you one that has conjugates. For this, I'd like you to just multiply it all the way out and see what you get. Now, wait a minute. You're like, Mr. Server, there's no multiply, it says to subtract. Well, then to be able to subtract them, you'll need a common denominator. So now I'm going to multiply both sides by something smart. I'm going to use, it's called the conjugate. And that is going to be multiplied here and here, one on each of these. And then by multiplying by the conjugate and adding it all together, you'll get it all together into one fraction. See if you can do that. It's called conjugates. We've practiced it, but we should practice it again. Okay. 1 plus cosine is the conjugate of 1 minus cosine. And 1 minus cosine is the conjugate of 1 plus cosine. Now you can't just leave it like that. You got to multiply it all the way out, and then they have a common denominator now, so put it all together into one big fraction. A lot of stuff simplifies. That times that is 1 minus cosine squared. And then, I hope you knew that since the denominators are the same, we can put them together into one big fraction, and 1 minus 1 means the ones disappear. And even more important, remember to distribute the negative, so that's positive cosine, so that's 2 cosine theta over 1 minus cosine squared theta. And some kids think you can cancel those cosines. No, you cannot. Because this is part of a subtract problem, so you cannot like cancel one of these cosine squareds. That's not allowed. And one thing you could do, though, if you needed to, you could swap out 1 minus cosine for sine squared. All right. Okay, awesome. Now, let's see if you can handle this one last tough proof. I'm going to pause for a second. Remember, your only homework for tonight is to find 4 problems to do, one of which could be a redo of one of the problems. Maybe you got it wrong in class. You want to try it again? I'm going to freeze the board for just a second here. Okay, so I'm going to prove this last one, and I understand that kids have to go, but I'm going to show you how you'd prove that this is equal to 2 tangent theta secant theta. All right, so my first step, if you want to try this at home, hit pause right now and then give it a try. All right, so here's your first step. You'd multiply by the conjugate, 1 plus sine theta, 1 plus sine theta. And I'd do the conjugate here, 1 minus sine theta, 1 minus sine theta. And then on the top, this one simplifies to 1 plus sine theta over 1 minus sine squared theta minus 1 minus sine theta over 1, and the denominator is the same here, 1 minus sine squared theta. Now, I'm going to put these together, and this negative is where all the trickiness happens here. That has to go there, and that negative has to be distributed to there. That makes the ones cancel on the top, and all I have left is sine, and this turns into positive sine, makes 2 sine theta over, and this is a lot like the last one, except I was supposed to prove that it's equal to 2 tangent secant. I got to finish with 2 tangent secant. All right, so then I'm going to replace this with cosine squared. 2 sine theta. You need to be quiet back there, please. Thank you. And I'm going to put cosine squared theta. And now I'm going to replace one of these cosine squareds. I'm going to split it up into 2 of them. 2 sine theta over cosine theta, cosine theta. That one right there, I'm going to turn into my tangent. And I'll have 2 tangent theta, and I still have a cosine theta on the bottom. So then the final answer, I'm going to break this into 2 tangent theta times 1 over cosine theta, because that's what that would be if I put a 1 up there. Okay, that helps me to see that the 1 over cosine, that's the same as a secant. 2 tangent theta secant theta. That's what I was trying to prove. Right up there. 2 tangent theta secant theta. Okay, that was a tough proof. An example of the level of difficulty that you got to be ready for on tomorrow's test. And that's all that I have for you for today.